Okay, so number 25. We have a guy here. His mass is 75 kilograms. 75 kilograms. And he's doing a chin up to get ripped. So this muscle. Okay, this is kind of a wordy problem, you know. The muscle can exert a force of 800 newtons as it contracts a distance of 7.5 centimeters. You want to put that in meters, 0.075 meters. Okay, so look, here's what's happening. Like if you were to look inside this guy's muscle here, you know, the force being exerted by the muscle is 800 newtons, and then the way muscles contract, they kind of like, I don't know, it's like, I'm not a biology teacher, but you know, like the muscles kind of like when you flex your muscles, the muscles kind of shorten up, you know. So look, they're talking about what happens inside of his muscles. So look, inside his muscles, is work being done? Are his muscles doing work? Yeah. So what's the work done by one bicep? You're just going to go force times displacement. You know, this is happening inside the muscle. So what's the force of the muscle? 800 newtons, and that acts over a distance of what? 0.075. So the work done by one of his biceps is 60 joules. But how many biceps does he have? 2. So you double that. So the work done by his biceps are 120 joules. Okay? Then it says compare this amount of work with the energy required to lift a 75 kilogram person 40 centimeters. So when he actually does this chin up, he's lifting himself 0.4 meters, right? When he comes up like that, he's raising himself 0.4 meters. So what's the energy required to do that? Well, look, what type of energy does he start with? Before he starts the chin up, does he have any energy at all? Is he moving? No. Any spring energy? No. Let's say that this is our 0 point right here. So how much mechanical energy does this guy start with down here? 0. As he raises himself up, what type of energy does he end with up there? Potential of gravity. The mechanical energy final up here, you know, it's going to be equal to the potential of gravity final. That's the type of energy he gained. So how much energy is required to move him up 0.4 meters? Well, it's going to be the potential energy that he gains, which is mgh. So his mass is 75, gravity is 9.8, and then he raises himself up 0.4 meters. So this comes out as 294 joules. So look, how much work did the biceps do? 120. How much work or how much energy is actually required to do this? 294. So here's the last question. Do you think the bicep muscle is the only muscle involved? No. Other muscles are doing work too. It's kind of confusing, huh?